Hello students. So in this video, we're going to start with a very important chapter known as trigonometry. Okay. A very important chapter, a very easy chapter also. Now, before getting into this chapter, everyone knows the highest mountain in the world, isn't it? And you also know the distance between Earth and the Sun. If you Google it out, you'll get the distance between the Earth and the Sun, Earth and the Moon, or the Earth and the Jupiter, all those stuff, isn't it? Now, we know the highest mountain in the world is Mount Everest, isn't it? But who is the person that measured it? We have got a mountain, okay, and it is the Mount Everest is said to be the highest mountain. Now, how did we measure this? Imagine, is it possible to measure such a big mountain, okay, using a tape, a measuring tape, using a measuring tape? Is it possible to measure it? Climbing the Mount Everest itself is a big task. Only few people so far, only few people have done it. Okay, it's not so easy, right, to measure the height of such a big mountain. But how do we know the height? If you Google it out, you will get the height of the Mount Everest, some 8,000 something feet, isn't it? Or the second highest mountain, or the third highest mountain. We have got different mountains, isn't it? And we know the heights of the mountain. Or if you Google it out, you know the distance between the Earth and the Sun. The distance between the Earth and the Moon is available. Now, how did we measure this? Did we hold one tape on the Earth and the another end of the tape on the Moon, and we just measured it using the tape? No, it's not possible. Then there might be some technique, isn't it? So one such technique is trigonometry. So trigonometry has a very beautiful applications, many applications. One beautiful applications which we're going to learn is heights and distance. Okay, with the help of trigonometry, we can find the heights of tall buildings, heights of mountains, and we can also find the distance between the Earth and the Sun, Earth and the Moon, and distance between any 2 points. Okay, so one important application of trigonometry is finding heights and distance. Now, before getting into the applications of trigonometry, let's learn the basics of trigonometry, which is a very new concept for a student who's studying in 10th standard. So let's learn the basics of trigonometry. In the upcoming videos, let's learn the applications of trigonometry. That is finding the heights of the mountain, distance between 2 points. Okay. Now basically this trigonometry word can be divided into three parts: tri, gono, and metry. Okay. Tri stands for three, gono signs for sides, and metry is for measurement. Okay. Basically trigonometry means three sides measurement. Trigonometry means three sides measurement. Okay. Now, remember in trigonometry, in this chapter throughout, we are going to use one particular type of triangle, that is right angled triangle. Right angled triangle. Okay, we are going to use only right angled triangle. Why right angle triangle? Because see, any triangle can be converted into a right angle triangle by simply drawing an altitude. And another important thing why we consider only right angle triangle is because this is the only triangle where you can find the relationship between all the three sides. That is the Pythagoras theorem. So you can write AC square as AB square plus BC square. That is, all the three sides are connected in the same formula, isn't it? So you can find a relationship in which all the three sides are connected. So that is why we make use of right angle triangle. Okay. And any other triangle, say suppose you got an equilateral triangle. Okay, simply you draw an altitude, you can convert it into a right angle triangle, two right angle triangles. Okay, so that is why we make use of right angle triangle. So what is a right angle triangle? If any one of the angle out of three, if any one angle is 90 degree, then it becomes a right angle triangle. Okay, and Pythagoras theorem is a very important concept. Okay, which we're going to use many a times. So what is Pythagoras theorem? Suppose if we have a right angle triangle, let's say ABC is a right angle triangle, right angled at P. So the hypotenuse is AC, isn't it? So according to Pythagoras theorem, the square of the hypotenuse, that is AC square, will be equal to sum of squares of other two sides. The other two sides are what? AB square and BC square. This is Pythagoras theorem. Remember, we always start with the hypotenuse. So find the hypotenuse, square it. That will be equal to sum of squares of the other two sides. So we are going to use Pythagoras theorem a lot. Okay. Now let's learn the basics. Okay. A very important basics. Let's take a right angle triangle. Okay. Let's take a right angle triangle. Let's say it is A, B, C, right angled at B. Okay. Opposite to B, that is opposite to 90 degree, we call it as hypotenuse. Okay. Say suppose we are studying about this angle C, and I'll denote it as theta. 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 It's just a representation for the angle. You can also take it as X and Y. No problem. Okay. So I'm interested in this angle. I'm studying about this angle, theta. Okay. Let's say we are studying about this angle. Now the side opposite to the angle that we are studying is known as the opposite side. And the remaining one will be your adjacent side. This will be opposite and this will be adjacent. Remember, we can identify the opposite side and adjacent side only if the angle that we are deciding is given, angle that we are studying is given. Suppose if the angle is not mentioned, okay, we cannot conclude which is the opposite side and which is the adjacent side. Suppose in the same figure, if I take this is the angle under consideration, if this is the angle under consideration, then opposite side becomes BC and the adjacent side becomes AB. Okay. Now all depends on the angle under consideration. Okay. Let's take another triangle, a right angle triangle. Let's say P, Q, R. Let's say P is 90 degree. So which side will be the hypotenuse? Very clearly, the side opposite to 90 degree, that is QR, is our hypotenuse. Now, which is the opposite side and which is the adjacent side? Now, we cannot decide which is the opposite side and adjacent side because the angle under consideration is not known. Suppose if Q is the angle under consideration, if we are interested in this angle, then the side opposite to this angle is PR, so it becomes the opposite side. So the remaining side becomes the adjacent side. Okay. So everything depends on the angle under consideration. Okay. A very, very important concept. Okay. So on that note, where you can find the opposite side and adjacent side, let's learn the first part of this chapter, that is trigonometric ratios. This is the first part of this chapter, trigonometric ratios. So what we do in this trigonometric ratios is we compare the sides of the right angle triangle. Okay, let's take a right angle triangle. Let me draw a right angle triangle. So let's say this is the right angle triangle ABC. A, B, C. Okay. So let's say this is the angle under consideration. So opposite to 90 degree becomes hypotenuse, and opposite to the angle under consideration becomes opposite side, and the remaining will become adjacent side. Okay. Let's move this a bit aside. Now, suppose we are comparing the ratio of opposite side. See, now the angle under consideration is theta. Okay. Now the opposite side is AB and the hypotenuse is AC. Suppose if I am comparing AB and AC, see, ratio means comparison, isn't it? So if I am comparing the opposite side with the hypotenuse, we have given a name to it known as sine theta. Okay. The full name is SINE, but we write it as SIN theta. Okay. We read it as sine of an angle, or we read it as sine theta. Sine theta basically is comparing the opposite side with its hypotenuse. So here, so sine theta can be defined as opposite by hypotenuse. In the figure, it is AB by AC. Okay, it is not always AB by AC. Remember, sine is what? It is comparing opposite side with the hypotenuse. So it is AB by AC. Okay. Now remember, sine theta is one complete thing. Okay, it is not like sine into theta. It's a complete one word. Okay, sine theta. So sine of an angle means you just compare the opposite side with the hypotenuse. That's what we are doing in sine theta. Okay. Now say suppose the next one, if we are comparing the adjacent side with the hypotenuse, we call it as cosine theta. The full name is cosine, but we write it as COS, cos theta. Cos theta is what? Comparing always the adjacent side with the hypotenuse. So in this figure, it is BC by AC. Okay. So let's get into the next one. That is, if you I'm sorry, if you observe, we have compared opposite with hypotenuse, adjacent with hypotenuse. Let's compare the remaining opposite and adjacent. Okay, that is known as tangent. The full name is tangent, but we write it as tan theta. Tan theta is what? Opposite by adjacent. Opposite by adjacent. That will be equal to AB by BC. These three ratios are known as the basic ratios: sine theta, cos theta, and tan theta. Sine theta is basically opposite by hypotenuse. Cos theta is adjacent by hypotenuse. Tan theta is opposite by adjacent. Okay. So now let's take the reverse. See, what we have done is we have compared opposite with hypotenuse. Let's do the reverse. Okay. That is, if you take hypotenuse by opposite. Okay. So that will be cosecant theta. The full name is cosecant. Okay. But we write it as COSE, cosec theta. But we pronounce it as cosecant theta itself or cosec theta. But cosecant theta is more suitable. Cosecant theta is the reverse, hypotenuse by opposite. That is, from the figure, it is AC by AB. Let's take the other one, secant. We write it as SEC theta, secant theta. That will be hypotenuse by adjacent. From the figure, it is AC by BC. Now let's get into the last one, the reverse of tan, that is adjacent by opposite. So tangent is the name, sorry, cotangent is the name, but we write it as cot theta, which is adjacent by opposite. Okay, which is BC by AB. So this 6 ratios are the important ratios, okay, which we have to remember throughout the chapter so that it will be very, very easy to solve the problems. Remember the first 3 ratios, that is sine theta, cos theta, and tan theta, we can automatically remember the other 3. Okay. Now let's a small hint or a technique to remember the 3. Okay. Sine theta, let's take the first letter S, is actually opposite by hypotenuse, isn't it? So opposite by hypotenuse, SOH. Cos theta, let's take the first alphabet C. Cos theta is adjacent by hypotenuse. And let's take the first of tan theta, which is T, that is opposite by adjacent. Okay. Now, let's say, let's take this S as sum and this O as of, H as her, C as children, Okay. Again, this a, let me write it properly. Let me write it in a vertical manner so that it will be easy. So sine theta is opposite by hypotenuse. Cos theta is adjacent by hypotenuse. Tan theta is opposite by adjacent. So this S stands for sum of her children are having trouble over algebra. So you can just remember this statement. Some of our children are having trouble over algebra. So here the first alphabet S stands for sine, and here O stands for opposite, and H stands for, let me highlight it using a different color. The first alphabets, sum of her children are having, okay, are having trouble over algebra. Trouble over algebra. So if you remember this statement, it's very easy to remember the ratios. So some of her I'm sorry, some of her children are having trouble over algebra. So SOH. So S stands for sine, sinus, O stands for opposite, H stands for hypotenuse. So sinus opposite by hypotenuse. So C, children are having CAH. CAH, C stands for cosine, A stands for adjacent, H stands for hypotenuse. TOA. So it stands for T stands for tan, O is for opposite, A is for adjacent. This is a small technique to remember it. I hope it will be useful. Now, if you observe, cosecant theta is simply the reverse. So if you remember the sine theta is opposite by hypotenuse. What is the reverse of sine theta? The reverse or the reciprocal of sine theta is known as cosecant theta. Okay, so sine theta is opposite by hypotenuse. Cosecant theta is hypotenuse by opposite. Similarly, if you reciprocal cos theta, what do you get? Secant theta. Cos theta is adjacent by hypotenuse. So hypotenuse by adjacent is secant theta. So tan theta is opposite by adjacent. The reverse or the reciprocal is cot theta, which is adjacent by opposite. Okay, so let's also write on that as a different heading, reciprocal ratios. Okay, this 6 ratios you have to memorize it. Okay, if we solve some 10 problems based on this, automatically you will remember the formula. It's not a big deal. You need not struggle a lot to remember, memorize this. So when we start solving problems, when we solve some 10 problems, automatically you will get to know the formulas. Okay, let's get into the next topic known as reciprocal relation. Okay, so as I told you, reciprocal relations. Okay, now very clearly, sine theta, the reciprocal of sine theta gives you what? Cosecant theta. So how do we write mathematically? We write it like this: sine theta is equal to 1 over cos theta. See, if both are equal, we write it like this: sine theta is equal to cosecant theta. But sine theta is the reciprocal of cosecant theta. If you reverse cosecant theta, you get sine theta. So we write it like this. Or in another word, we can also write cosecant theta as 1 over sine theta. Similarly, for the other things, you can write tan theta as, or let's start with cos theta as 1 over secant theta, or secant theta as 1 over cos theta. So the next one is tan theta. Tan theta can be written as 1 over cot theta, or cot theta can be written as 1 over tan theta. And these identities are also very, very important. See, it's very easy. So what do you get if you reciprocal sine theta? We get cosecant theta. So how do we write mathematically? Sine theta is equal to 1 by cosecant theta. So reciprocal of sine theta is cosecant theta. Reciprocal of cos theta is secant theta. Reciprocal of tan theta is cot theta. How do we write it? Tan theta is equal to 1 by cot theta. We say it like this. Tan theta is the reciprocal of cot theta. While saying, we say it like this. But while writing it, we write it as tan theta is equal to 1 by cot theta. Cot theta is equal to 1 by tan theta, and so on. Okay. And another important relation known as quotient relation. Let's do that. A very, very important one. The last important concept which are useful for the problems. Okay. Quotient relation. Now, if you observe carefully, tan theta can also be written as sine theta by cos theta. So tan theta, what is the formula for tan theta? We have learned it as opposite by adjacent. But tan theta can also be written as sine theta by cos theta. Let's prove that here. Proof. Let me do it here. See, let's consider sine theta by cos theta. Consider sine theta by cos theta. Now, what is sine theta? It is opposite by hypotenuse. And what is cos theta? It is adjacent by hypotenuse. Now we know that if you got something like this, a by b divided c by d, what do? A by b as it is into the reciprocal d by c, isn't it? So we'll use the same logic here. So therefore, opposite by hypotenuse as it is, reverse the denominator, reciprocal, hypotenuse by adjacent. So hypotenuse gets cancelled. We are left with opposite by adjacent. What is opposite by adjacent? Opposite by adjacent is tan theta. Remember, we started with sine theta by cos theta, but we ended at tan theta. So this is the proof of it, as very small proof, but not important from exam point of view. I've just shown you how we have derived this. Okay. Now, so tan theta is sine theta by cos theta. So what will cot theta become? So as I told you just now, cot theta is the reciprocal of tan theta. So you just reciprocal it. So cot theta will become cos theta by sine theta. You can prove this by on your own. It's a very easy proof. You can do it. Okay. So these things are very, very important. The basics of trigonometry. The first one is trigonometric ratios. All the 6 ratios you must remember. And I've also given you a small hint. There might be different hints, also different techniques to remember it. This is a technique which I know, which I'm sharing with you. After this, the reciprocal relation. See, if you remember the reciprocal relation, it will be very, very useful. And this reciprocal relation is very, very important. Okay. We're going to use it in trigonometric identities a lot. Okay. So sine theta is what? 1 over cosecant theta. How do we say it? We say it as sine theta is the reciprocal of cosecant theta, or cosecant theta is the reciprocal of sine theta. But while writing, we write it as sine theta is equal to 1 by cosecant theta. And another important relation is the quotient relation, where tan theta can also be written as sine theta by cos theta. Cot theta can also be written as cos theta by sine theta. A very, very important relation. So I hope you guys have understood. So trigonometric is as having many application. One such application is heights and distance, which we'll be doing very soon. Now, to do that, to solve problems, we need to know the basics, which we have discussed in this video. I hope you guys have understood this. In the next video, we'll start with the problems. Thank you, students.